When Lightband stopped maintaining Play, everyone thought Play was dying. When Akka changed their license, they said Play was dead. Well, guess what? The Scala community, which allegedly is the worst community or whatever, stepped up and released Play 3 with Spaco instead of Akka, Java21, and Scala 3 support. So let's take it for a spin. Hey, Vlad here from devinside.com. Welcome to another video. When Play 3 came out, I thought about making a basic Hello World tutorial, but the truth is, I'm not a big fan of huge frameworks. That said, the truly great frameworks, like Play, allow you to grow out of them. So today I'll show you how to replace the majority of the Play framework with something else. Now, I didn't manage to squeeze it all into one video, so there will be one more after this. I'm moving to another place though, and so it will take some time until the next video is released. There's nothing to worry about though, because even this part is packed with all the things that you see on the screen, and I'll tell you all about them right after the message from our sponsors, ScalaJobs.com, RustJobs.dev, and SoftwareMill.com. Check out the links in the description below if you're looking for a job or JVM industry experts who can help you accomplish your mission. This video is also brought to you by awesome people like yourself who support me on platforms like Patreon, GitHub sponsors, or by joining the YouTube membership program. Your contributions allow me to pay for a video editor and a thumbnail artist who free some of my time, which I usually end up spending with you, whether it's during live streams or answering your questions on Discord. There's many of you and only one of me, so all it takes is $1. Thank you. All right, now as already mentioned, I built a Hello World app in Play, and I replaced many parts. So now there's ZO, ScalaTags, static dependency injection, HTMX, and a multi-build with the diamond architecture. And also there will be much more in the second part, potentially second and third part. All right, now this is pretty much the Hello World that I built. It just shows you the current time, and also when we click refresh, I'm using HTMX to replace the content of the of this H1 tag, right? So we're replacing the inner HTML of the H1 tag without reloading the entire page. Let me actually show you the network tab. Let me refresh the page real quick. Okay, so as you can see, the index page is pretty simple. There's an H1 tag and there is a button that when clicked, it's going to send a GET request to the refresh endpoint, and it will find the previous H1 tag, which is this one, obviously, and whatever comes out from the refresh token, which is usually HTML when you're dealing with HTMX, will replace the inner HTML of the H1 tag. Okay, so if I click on refresh, there will be another request over here, and it doesn't even return HTML. It's a simple string. Okay, so this is a very, very basic app. So if we look at the elements, every time I click refresh, the H1 tag is changing. All right, so here it's running. As you can see, it's well, I don't know if you can see. I mean, I called it Play 3, but this is basically a Play 3 app with, again, Scala 3. It runs on Groovy and 21. It worked pretty much like a charm. A couple of things didn't work. I'll mention them by the end of the video. Okay, so this is the app over here. So pretty much any Play app, the central point of any Play app is this routes file. Okay, so let me open it real quick. And now this is a multi-build. So if you have seen my videos about the diamond architecture, I basically split up all of my applications into at least 4 parts. There's the core at the top. There is how I deliver my application to the users, which in this case is via Play, right? So Play an HTTP web server, and it might need something. Typically, at least it's persistence. This directory is actually empty. And there's also main where everything is assembled together, right? So this is the dependency injection point. All arrows are pointing to the core. There are no dependencies between the delivery and persistence. Okay, so if you are not familiar with Play at all, it works as an SPT plugin, and so the SPT plugin is included for delivery and for the main. All right, and so yeah, again, the core of pretty much any Play app is this routes file, which uses a DSL, which will pretty much describe your endpoints. So here are 2 endpoints. If we hit the slash, if we hit the refresh. Okay, and so the way this works is that Play will use usually dynamic dependency injection, uses a library called Juice to create an instance of a class called controller. There will be only usually one instance of this class for the entire runtime of the application, and then every time you hit the route, it will use some magic to find this particular instance, and then it's going to call this particular method, which currently doesn't have any parameters, but you could have parameters. Okay, so there are 2 routes, one instance of the controller. Now, I'm doing static dependency injection, which means I'm actually the one creating this controller class, and I'm giving it to a so-called router. So the router is a class, the source code of which is being generated by this SBT plugin, right? So something looks at this file and it generates a file which is going to be somewhere in the target folder over here. Routes, router, this one over here. So this class is being generated based on that. So it says, okay, give me this error handler, give me some assets, give me some other things, but most importantly, give me this controller, right? This use case one controller, because it will need to find it whenever we hit these routes. It's going to find this, the instance of this class, and it's going to start calling methods on them. All right. So we're going to start by looking at the file called main.scala, which is in the main, which is where all the dependency injection is, right? So this is relatively pretty much straightforward from their docs, how to do static dependency injection in Play. You create a class, you extend an application loader, which comes from Play API, and then you override this method called load, which will give it the context, and then you do something with this context. Usually the way I do this, I try to keep the main to like one line, and in this one line, I'm creating a program, which is a file that is right next to it over here. I created this tiny abstraction. I'll show it to you. I'll push the whole thing to GitHub, and you can have a look at it later. But essentially, it's pretty much copy pasted from the documentation, cleaned up a little bit, so that the usage of it looks very comfortable. I'm going to jump into it real quick, but I'm not going to explain it much because, again, the majority of it is copy pasted from the documentation. I'm saying all of this because it looks a little bit complicated, right? So there's there are a couple of abstractions, there are context functions and things like this. I also created my own alias for context functions. I call it using, right? So this is just an alias for context function. Okay, and if you're not familiar with context functions, this is a Scala3 feature which allows you to declare the fact that the parameter list to a method is implicit. Okay, so this I is implicit. So this information is baked into the type, and I just created this alias over here. So essentially, in order to produce this function over here, we're going to need to use controller components, right? Which are going to be passed around implicitly, right? And so we're instantiating basically this Play app, and somewhere inside of this Play app, there's this thing called controller components. And whereas in Scala 2, you would need to do something like this, right? And then you would be able to just leave this out, or with a rather newer syntax, you would say something like given x column controller components equals, right? You could do something like this, given like that, okay? And you don't even need the name. You can do something like this without the colon, okay? Or you can just convert something that is being used explicitly into something that is going to be used implicitly by using the word using, right? And then you can just use controller components the way I had it before without doing that thing, okay? Tiny little crash course on context function. Okay, so this is how we're creating a player. We're using this teeny tiny little abstraction, and now we're creating an instance of this router, the one that I showed you, right? So based on this DSL, this class was defined, and because I used only one class, only one controller in the package called use case one, the constructor tells me, okay, well, give it to me now, and this is exactly what we're doing over here, right? So we're creating it over here, and this context function was required because in order to instantiate the controller ourselves, we need those controller components. So over here, actually, we are going to use the controller components, okay? And due to context functions, the implicits are so well hidden that you only see them in the types, right? So it's over here, but you don't see it anywhere over here. Like usually in the past, you would need to keep passing some sort of implicit parameter here, right? Something like this. This is how it would usually look like. So you would see it somewhere, but in Scala 3 with context functions, you're only going to see it in the types. Okay. Now, use case one dot controller is actually a top level definitions because we're in Scala 3 and it's over there. So if I go to the definition, this is a file that I usually call DI, dependency injection. And this is very simple dependency injection. I'm just creating a controller which needs a boundary, which is just a trait that describes how to talk to the business logic. So the controller needs to go through some boundary to talk to the business logic. But there's this complexity over here because we're doing play. And so in order to instantiate the controller, we're going to need controller components. And so they're being passed implicitly to the constructor of the controller. Okay. Now, the boundary itself is actually not spectacular, except for the fact that we're using Zeal. So now we're all of a sudden in the core. The implementation of the boundary is this business logic. Again, we're in the core. Basic implementation of the trait. The type over here is inferred. again, because it's Scala3, and we're just passing it the current time. Okay, I'm doing this end trick because usually I'm enabling the strict null checking in the build. I actually disabled this time. In this file over here, it's actually disabled because Play generates a lot of Scala source code, and this is a little bit too strict, right? And so there will be warnings over there, or in fact, in this particular case, actually errors, but I still left this and then over here because it didn't really bother me. Okay, so if we were to go back to the controller is actually the most interesting part. Okay, so now we're in the delivery portion of the application where you have this controller and a couple of abstractions that I built around them, right? So because we're instantiating the controller ourselves, we need to give it the boundary so that when the route gets hit, we go through the boundary and do something on the business logic, right? So when we hit index, there's a couple of stuff around it, but the majority of the logic here is that we just go straight to the boundary, right? We hit the route, we go to the boundary, asking it for the current time. And when the time comes back, we're wrapping it into an HTTP 200, and we're using ScalaTags over here, not twirl, to actually return HTML. We're going to get to that portion in just a second. Now, as I already mentioned, in order to instantiate a controller, we actually need these controller components that I'm passing around implicitly. Fun fact, we actually don't need them anywhere over here. We need them in this fancy controller. And I call it fancy because in Scala3, traits can have constructors or other parameter lists, right? So this fancy controller, it has an implicit parameter list, and it extends a base controller, which comes directly from Play. And this base controller requires controller components. Okay, so this implicit parameter is actually going to override this controller components. And so you kind of don't really need to understand this. Once you have it, all of your controllers will look like this, right? They just need this tiny portion. The rest looks like a regular class, like a regular controller. You give it the boundary, you do something with the boundary when the route is hit. All right. Now, this thing over here simply converts a zero into a future. We're going to jump into that. I'm not going to explain too much about it. To be fair, it's just a couple of lines because it's Scala3. There's a lot of information in the types. There's a lot of stuff in here. You can have a look at it at your own pace, but essentially it converts a zero into a future as long as your zero either doesn't fail with any errors or if it fails with a throwable. And if there's any scope involved, this thing will close it. All right. So let's go back. So essentially, this is a zero, and it's going to be converted into a future. Usually with Play, you would do action.async, and then you can return the future. Okay, so this is what is happening over here. The next thing over here is the ScalaTags template instead of twirl. I made it look like twirl. Usually these views, they would be generated into, there's a folder called controllers, and there would be another folder called apps/views. So I made it look like that, but they're actually not there, right? So this controller is over here. I put the views over here, and again, I made it look like twirl, but this is actually a regular method, and we're using ScalaTags over here. If you're not familiar with ScalaTags, it simply gives you a lot of HTML-looking methods, and at the end, you can call .render or .toString, and a HTML rendered, as a string comes out. Okay, so I made everything look like the default main template. So I rebuilt the default main twirl template, which is over here, pretty much fits into one file. And this is based on the place jittered template. The default main template looks like that in twirl. I basically just rewritten it in ScalaTags, and I added HTMX over here because HTMX is popular these days, and I actually kind of like it, so I included it. Okay. Now there's one tiny thing that you need to know in order to make this thing work. I actually have created a teeny tiny implicit. I called the file package, but you don't need to have package objects in Scala3 anymore. So if you look over here, there's this teeny tiny thing over here that would make this this one line work. Okay, so it will essentially do a toString on this route and put it into a source, which in this particular case is exactly what we need. If you actually look in there, there's also things like absolute URL and relative URL that will require a request header. And the initial version that I built for this actually used that, but then I realized that I actually didn't need it because it simply worked with a toString. So my types became simpler. In the beginning, I would have something like this over here, right? I would use this something like request of any content and doc type, because in order to calculate the absolute URL or the relative URL, I would actually need something like this. But now I don't need this because a simple toString made it work. Okay, so let's actually go back and let's look at this one. So this is exactly what you saw. The title is welcome to play. We're creating H1 where we are rendering the time, which is just an extension method that I created to render the time in this pattern. And then we have a button. And when we hit the button, we are going to call get on this route. Play has a reverse router, and this is how you get access to it. And the target is going to be the previous H1 tag, and the title of the button is going to be refresh. Okay, very, very simple. The refresh looks even simpler. It's a simple method. There's not even any HTML involved because it simply returns a string. All right. Now, an interesting part of it here is that ScalaTags does not have built-in things for HTMX, but it's super trivial to build it. It's basically just a couple of vowels that wrap a couple of strings, right? So this is this stuff, and well, pretty much all of these lines is the just a few lines that I needed to make this portion of HTMX work in a type safe way. So if you look at this and if you compare this with Twirl templates, everything here is type safe. Everything is typo safe, at least. The only strings over here are literally what is written on the button and the title of the page. In fact, let's have a look again. This is the title of the page, welcome to play, and this is what's written on the button. Right. As I already mentioned, this app doesn't have any persistence, but we will have something like this in the future videos. At least that's what I'm planning to. My life is a bit chaotic these days, so I can't promise that. But yeah, that's pretty much all I have for you today. It pretty much worked like a charm with a couple of exceptions. Number one, I already mentioned, Play generates a lot of Scala source code. And so if your build is configured in a very strict way, if you're doing a lot of linting and stuff like this, or Scala3 came with this indentation-based syntax, and maybe what they generate does not use the indentation-based syntax, there might be some conflicts over there. And the second part is that Scala3 finally has the wconf configuration flag that Scala2 has, but it's not as powerful yet as it is in Scala2. In particular, in Scala2, I am doing something like that, which would basically silence all the linting warnings that are for the files that are in the target folder. And in Scala3, this source filter is not available yet for wconf. All right. And because of this, if you look over here, I'm currently disabling all the linting rules, but if I had them enabled, you would actually, all of this stuff would be yellow over here because of these classes over here that were generated, right? So they don't fit into my linting rules. Number three, Play supports 21, and I actually, as you can see, I ran it with Play21. I'm sorry, not Play21. Java21 came with generational as EGC, and I tried to enable it, and it did work. However, because I'm using GraalVM, I actually stumbled on an issue in GraalVM. As soon as you enable generational ZGC, it actually doesn't support the Java-based incremental compiler, right? Which is the whole thing that came with the GraalVM, right? This optimizing compiler. And so there was a warning that so now that I have enabled generational ZGC, it can't use that compiler. Now you can silence the warning by simply disabling the this compiler yourself, but it's obviously not the purpose. So in the end, I just threw it out. And also the fourth issue that I had was again, related to generation of ZGC, is that Metal started freaking out. Like I even, I deleted all the folders, I turned, bloop off. I even restarted my whole computer. As soon as I would start VS Code, it just would not load. Like Metals would just not even load. Like there was not even a project. I didn't even come to the point where I would import the project. Just Metals would just not load. It took me a while to figure it out, but yeah, it was because of the generations you see, and therefore in the end, I just disabled it, right? So these are the flags that I'm using. And by the way, the majority of this app was generated was one of my generate templates, and then I just added play on top of it, right? And so if you look at the build, there are four sub-builds, right? So this is a multi-build. So there's a core of the application, then there's delivery, which enables the Play Scala plugin. There's a persistence, which is currently completely empty, but it's going to come in the upcoming videos. And in the main, I'm also using Play Scala over here, right? The plugin. Also, one thing to note, if you're doing it like this, your assets should be in the main, right? So the default main.js and main CSS. You can verify this by look into the network tab, and if you reload, these need to be found, right? There's nothing in them, but at least they need to be found. So you can't, unfortunately, put them into delivery. This is just how SBT works. Actually, there's probably a way to configure SBT to do this, but there's no need. So you kind of have to split up your delivery a little bit between the delivery and the and the main over here. As for example, there's a conf over here. I'm actually not even sure if it's necessary these days, but I think it is. I just put it in there because, because I'm used to putting it in there. Cool. I hope you enjoyed this video. Check out the previous one, and I see you in the next one. For now, as always, it's Vlad from devinside.com. Don't forget to like this video if you did, subscribe if you want to improve the developer inside you, and if you wish to support tech education, please consider doing so on platforms like Patreon, GitHub sponsors, or by clicking on the join button right below the video and watch my videos before everyone else. And most importantly, take care.